That's an excellent start. Try again. Good morning. Thank you. As you can hear from my voice, I love Copenhagen. I'm always glad to be back here. So how many of you build ASPNET core applications today or in the near future? Okay, and how many of you have to secure them? Like, is your job to secure them? Okay, so to be honest, I just did a 2-day workshop on this topic, so there is more to be said about that fits into 60 minutes. So it's an overview, okay? So it's basically for people that maybe are new to that and want to get like the big picture, what is in there in ASP.NET to help me with the security architecture of my application. Or maybe you know bits and pieces of it and you want to make sure you're not missing anything, yeah? So we help our customers evaluate basically if ASP.NET Core is the right platform for their next generation app or the app they're planning to build and so on. And that there are many things that make up this platform. I only know about security. Yeah, that's all that's all I can talk about really. So and for those who have been following ASP.NET Core is many things have changed, right? So the authentication system was brand new in 1.0, got rewritten from scratch in 1.1, got rewritten from scratch again in 2.0. The good news is, now it's pretty stable. Yeah. So from a security point of view, that's good news. I also had a look at 3.0, the current preview 3, and again, it looks pretty stable. So no fundamental changes anymore, at least as of today. Okay, you never know. So this talk, as I said, is an overview of the things we have today and a little bit of an outlook what's coming in 3.0. So my name is Dominick. The idea is I have a couple of links on these slides for demos and documentation and so on, and I uploaded those slides to Speaker Deck. So if you want to, if you need one URL, then take get the Speaker Deck one, download the slides from there, get the further links from there. So I'm working with the ASP.NET team for a long time. I'm one of the authors of this thing called IdentityServer, which is an open source implementation of an OpenBody Connect server, which is pretty close to the metal in ASP.NET. So whenever the ASP.NET team decided to change something internally in their security stuff, it broke us pretty much the first. So that's where basically all the my gray hair is coming from. Okay, so who is old enough to remember this? How many of these 5 options actually work? Any idea? None works, you're right. You mean the none option or none of them? None works, yes. Which one does work too? Windows does work, you would hope that, right? Forms works as well. Has anyone ever done a passport authentication? You can't, because it never existed. Yeah, it was a product from Microsoft which got pulled before the very first version of ASP.NET, and nobody updated the enum. Okay? Federated was the second attempt of Microsoft to do token-based authentication in .NET 4.5. Before they released it, they removed it again, but nobody updated the enum. Okay, so yeah. I spent even 14 months of my life documenting all this. And if you get one takeaway from this talk, never write a book. Okay, it's not worth it. It was called ASP.NET 2.0. It got released, and 3 weeks later, ASP.NET 3.0 got released, which made it outdated, even if nothing has changed in between, but So I'm assuming none of the 3 people are in the room that read this book? No? Yeah, I thought so. Anyways, kind of like the scene for modern applications, is kind of, like, I mean, there's nothing new, right? We're building front ends, we're building back ends, we're building back ends for back ends. Yeah, it's just that the technologies change, the requirements change a little bit, the circumstances change, right? While 10 years ago this was all Microsoft Windows .NET. Today, we have a wild mixture of .NET and Windows and Unix and containers and iOS and Android and Chrome and Firefox, and I think that's it pretty much. Yeah. So 10 years ago, we relied on the operating system to do the hard work for us, right? Enable Windows integrated authentication in IIS, job done. This doesn't work like that anymore, so basically, because we have this operating system independence and the cross-platform and these different runtimes, all of the security stuff these days is happening at the application level, right? The protocols are at the application layer, they are running over HTTP and so on. In other words, it is actually the job of ASP.NET Core in your system to provide all these things. Yeah? So let's have a look how that works. You typically, when we talk about a modern security architecture, factor out certain security functions. One would be authentication. So you would be crazy if in 2019 you would write your own login page inside your application. You want to make that a central, a shared service that your applications can share. You get things like single sign-on, and basically allow the business developers to focus on the business and the security guys to focus on security. Yeah? So that's typically called an identity provider, and you also want to have something that deals with authorization. So after you know who the user is, you want to know what is this user allowed to do. There are many ways to implement that. I just put it there as a separate box. It doesn't necessarily need to be its own server, but it's definitely separate from the identity. Yeah? So I've seen many people trying to conflate the two concepts, identity and authorization, and it doesn't work. Yeah? I would need another talk to explain to you why. If you're interested, come to me afterwards. But it's complicated. Okay, so my idea is basically to start from the ground up and work our ways up the different layers of ASP.NET and what the security of these layers is all about. Let's start with hosting. So you might have heard that Microsoft built their own new web server called Kestrel. It's a cross-platform web server. And I wouldn't even call it a web server, it's more like an application server. It executes exactly one application, which is your application. It's not like IIS, where you have virtual directories and application pools and all these things. So, but by default, ASP.NET Core will execute on the Kestrel application server. There are more options these days. You can host in IIS and so on, but if you are not on Windows or you want to have the same server on all of the platforms, then you probably end up using Kestrel. You might have heard that writing a web server is hard, especially from a security point of view. Yeah? So in the 1.x times, Microsoft said yeah, you can use Kestrel, but never ever expose it directly to the internet, because we are not sure if the wild, wild west will be friendly enough to our new little web server. So that has changed in version 2. So if you want to, you can now expose Kestrel directly on the edge. Lots of penetration testing has been done. They found a couple of bugs, or many, I don't know. And this is now a fully supported architecture. Yeah? And some people do that. As a security person, I still feel a little, I don't know, torn here. I personally prefer to have a reverse proxy in front of my web server. Yeah, like Nginx, Apache, IIS, or maybe a load balancer. That's my preferred architecture, but this is fully supported now. Yeah? If you want to do that, maybe in the microservice context, people like the idea of having a lean, very small web server, bring it up, run, host a service, whatever. If you are hosting directly on the internet, be prepared to tweak some things, right? So Kestrel is a very small and very fast web server. And has a lot of tweakability, yeah? And you have to figure out, yeah, which buffer sizes do I need, yeah? Which limits do I need to set, yeah? And there's always a fine line between performance and denial of service attacks, yeah? So be careful with that. They now support HTTPS, and actually, if you open the newer templates, they have HTTPS turned on by default in Kestrel, which I personally think is not really necessary, because I'm not seeing any benefit of running HTTPS on my local host. But well, it's HTTPS by default now, which probably sounds good. What's pretty cool is they support both static certificates, where you just have a static configuration, or they support also SNI, which stands for Server Name Indication, where you can host multiple DNS names on the same server, for example, and depending on what's coming in, you can get the right cert and do the HPS tunnel with that as well. So that's Kestrel. Once you are beyond the hosting layer, then you are entering the ASP.NET Core, runtime, if you like, which is essentially a process that loads .NET, or .NET Core. Right now, you have the choice. In the future, ASP.NET 3 will not run on the .NET framework anymore. So, in my opinion, you should move away from that as quickly as you can. On top of that, we have ASP.NET Core. Then we have this thing called the middleware pipeline, which basically is just a way to automatically execute code. And the middleware itself is typically pretty simple. It pulls the real services from a DI container and uses that to do its job. So it turns out all of the security features in ASP.NET Core are actually services living in a DI container and some middleware that makes use of it, if it needs to be executed automatically in the request pipeline. So the first service I want to talk about is the one that not many people know, but it's going to bite you on deployment day if you are not aware of it. Who can remember this here? Yeah, the machine key, right? So the expectation in the old ASP.NET was that you have a master key for your application. You have to come up with that yourself, or you go to some website, machinekeygenerator.com, and then you paste that key into your web config, and then this key is used to protect your cookies and all these things, right? So this is basically the most important string in your application, because whoever can steal that key from you, he can create cookies that look like as if they are coming from you, okay? Which is a very bad thing. And because this string was so important, we put it into clear text into a config file on our web server, right? That was a brilliant idea, It was a 90s design. These things end up in source control, and if you open source this thing, it ends up on GitHub. If you're not careful, Google indexes your config files, right? I mean, try this, you have fun. You probably can deduct what that means, this search syntax here, So that's the first thing they had to change, okay? So they have a new API in ASP.NET Core called the Data Protection API. And the first thing they had to fix was to get that key material outside of the application directory. It must not live inside the application directory, otherwise this will, it's the chance of exposure is very high. So that's what they did. They have some defaults where they store it by default, and it is very developer-friendly, because on your local dev machine, they just take your profile and store it in there. Okay, I think I have a screenshot of that. Yeah, that's how it looks like, So it's in users, Dominick, app data, local, ASP.NET, data protection keys. And that's how a key looks like. This API is zero maintenance from your point of view at development time, because they just create that file and they're just using it, The problem starts when you're starting to deploy the application, because, hey, on the deployment server, this file must live somewhere, okay? So, if you're deploying to Azure, right, I mean, they put some magic pixie dust over your application and it just works, Because what they do under the covers is they provision a file share that is shared between all the instances of your web app, and then they put that key container on this file share. If you're doing anything else than Azure Web Apps, you have to think about where to store this thing. And the options are in a database, in a cache, blob storage, whatever. Okay, but you have to have this thing, otherwise your applications will break the moment they are being load balanced, right? Because all of the nodes in your cluster must have access to the same key material, otherwise it'll break, okay? So let me show you a demo of that. And I'm showing you that because I have many customers that have this unpleasant experience on deployment day, and that's the worst day, right? To have unpleasant experiences. So basically, you can see this data protection provider is just a service living in a DI container. You can use it yourself. Microsoft uses it internally, and then you can just protect data and unprotect data. And Let me show that to you first. And be aware, all these demos are really, really boring, because that's how security demos should be. Yeah? If security is exciting, well, then it's probably in the way of many people. So, encrypting a string, yay. Okay? That's your protected string now, and now you can basically transmit this, or put it on a query string parameter, or round trip it, whatever. And when you unprotect it, the system makes sure it hasn't been tampered with and manipulated, and so on and so forth. Yeah? The other thing I did in this application is something you should never ever do. Probably a bad introduction to the feature, but I persisted the keys to the file system in my current application directory. Why? Well, just to be able to show it to you easily, right? Here it is. Okay, the very first time I used the API, it created this key container, and here it is. Okay, so now let's simulate your load balancing, yeah, and the application doesn't have access to the key anymore because, well, I'm deleting it, yeah. So, and I'm shutting down the server as well and running it again. Okay. And now imagine a cookie comes into your application, ASP.NET tries to unprotect it. It will fail. Okay. It won't fail with an unhandled exception in the cookie case, but you will see these exceptions in your log files. And that means basically somehow you are not configuring your key container in the right way. Okay? So, sounds boring, but it's very important because, as I said, the moment you're load balancing, this will fail if you haven't planned for it. Yeah? Okay. Besides that, this API is brilliant. Yeah, I mean, they use all the bells and whistles, big keys, the right algorithms. They auto-rotate your keys every 90 days. They do all the right things, and really the only thing you have to do is give them a place to store it. Okay, good. Yeah. So who's using that? Well, cookies are using it, and the forgery is using it. OAuth, the state parameter is protected with data protection. If using temp data, yeah, these things, you can use yourself, as you've just seen. So if you have the need to temporarily protect certain data while you're passing it around, that's a thing to use. Okay? So, data protection is actually needed by the authentication system, as you can imagine, because there is a need to protect data. Yeah? So let's have a look at that next. So the authentication system is by far the best thing we ever had in .NET. Yeah, it's super flexible. You can use as many different authentication methods as you want. You just throw them in a DI container. We have an orchestration engine that makes sure no one steps on each other's toes. And for the very first time, this actually works. Yeah, I mean, for people who are doing OWIN or other things, they know that this is a bit tricky sometimes. So basically, when you look at the authentication system, we have a couple of options here. Well, one is you do your own authentication, obviously. You bring up your name and password page, you go to your database, and so on. Yeah? Or you are using some sort of social providers, right, like Google, Facebook, Twitter, and Microsoft are included by Microsoft, which are proprietary. And you see here, there's a community project which has like 40 plus more of these proprietary providers, like, in really important things like Battle.net, for example, or GitHub or Untapped. Yeah? When you look at standard space protocols, Microsoft supports OpenBody Connect, obviously, and WS Federation. So if you have like an ADFS server, for example, or that's the main motivation really to have it, yeah. Or you're working in a bank or something like this, WS Federation is still a thing. SAML is not included by Microsoft, but there's a guy from Sweden called Anders. Whenever you have a SAML problem, just call him. He's the right person to talk to. Don't call me, please. And yeah, he produces an authentication handler for ASP.NET Core that works really well with SAML. And then the last thing that's included is JSON Web Tokens, obviously, when you're doing token-based API authentication. Yeah? Then we have the notion of a session, right? Signing in a user, signing out a user, and so on. There's a whole abstraction for that. By default, it's implemented on top of cookies, right? Because that's what we do in the web. But you can exchange this implementation if you want with something server-side. Yeah, that's boring. that is how you interact with the authentication system. So there's one service living in a DI container called the Authentication Service, and this implements the 5, I don't know, motions that you typically do in a web app. Yeah, you are authenticating someone, you're signing someone in, that starts the session, signing someone out, stops the session. Challenge means you signal the system authentication is required. Forbid means that the user is not allowed to do whatever he's trying to do, despite being authenticated, yeah, which makes it different than challenge. Okay, so that's that. We don't need to do this. Session management, yeah. So as I said, web applications are stateless, right? So we need to find a way to do state with regards to having like authentication sessions. This is typically done with the so-called cookie authentication handler. And it does things, that you would expect, like, setting the cookie name, setting the expiration, sliding versus absolute, and so on. They support same-site cookies now, out of the box. All of your cookies are same-site mode lax, which means they are much more resistant against cross-site request forgery attacks these days, yeah, which is really good. And I'll show you a big demo at the end, which brings all these things together. But just to give you an idea how that session management works, it's basically, you authenticated the user somehow, or you went to some authentication service, but ultimately, you're modeling the identity of the user as a list of claims, right? That's the abstraction that they are using. So you're creating a list of claims, you put the claims in there, like the subject ID and the name and the email address, and so on. Then you turn that into a claims identity, and then you can associate additional metadata with the authentication session, which is not claims, but maybe something you want to keep together during the time of the authentication. Maybe you want to store an access token for the user, so that whenever this user, you want to call an API on behalf of that user, you just go to the session, get the token, and use that from there, okay? And then, you basically call sign in. You pass in this claims principal, you pass in the properties, and that's basically what sets the cookie, yeah, typically. And when you're done with the session, you call sign out, which then deletes the cookie again. Okay? So that's how that works. It's pretty simple. The cookie handler has some advanced features. So for example, you can tap into the lifetime events, like for example, there's an event that gets fired every time the cookie comes into your application. That gives you a chance, for example, to say like, hey, even if this user is authenticated, is he still a valid user? Yeah? Or maybe someone disabled him in the database, and now would be the time to get rid of this cookie, yeah, even if the cookie itself would be valid. You can also, another common thing to do is go to the sign out event, so that you can do some cleanup at sign out time. Yeah, maybe you want to get rid of tokens or clean up databases or caches, things like that. Yeah. And as I said, the session storage mechanism itself is replaceable. So as I said, by default, they're using cookies. But as we all know, cookies have certain limitations. Yeah? So a cookie shouldn't get bigger than 4 kilobytes. And different browsers have different upper limits, how much they support per domain. And the most problematic one, it turns out, is Safari. They only have 8 kilobytes per domain. So if you have many applications running on the same domain, and they all set cookies, the last one wins. If you're hitting this limit, so you should make sure the cookies stay small, okay? And it's also really hard to troubleshoot that, I can tell you. So one option that actually is fully supported by Microsoft and comes out of the box is just plugging in a Redis cache instead. So that instead of putting all the data into the cookie, they just put a GUID in the cookie, and the GUID has a representation in the cache, and when the cookie comes in, they get the data from the cache, and your application is unaware of that. It's happening in the pipeline, so to speak, yeah? That's that. Then let's talk about external authentication. So external authentication is a special case, if you like, because now you have to deal with two systems, right? There's a wire between you and the authentication system. So an external authentication process typically looks like first you challenge, which means you send the user somewhere else, yeah, like to Google or to your company's authentication system. And then you're waiting for a callback coming back from this external system, and then the callback is doing all of the protocol work to validate what's coming back, validating tokens, and so on and so forth. Yeah? Again, this is completely abstracted. You don't need to know how these things work unless you want to know how these things work, yeah, which is always a good idea. But again, they're just having, you saw the 5 methods, yeah, so challenged is the thing that does the sending away, and the callback is implemented by the handler as well. And that's a very typical configuration if you're connecting to an OpenBody Connect based system, yeah, where you basically have the cookie, which is the session management mechanism, and then below that you're configuring your OpenBody Connect handler, and typically the only really things you need to know here is the so-called authority, which is the base address of the server, your client ID, your client secret if you have one, and then all of that is being taken care of by the handler itself. And the very last thing, before I show you how it all works together, is API authentication, right? So Microsoft ships support for JSON Web Tokens. So if you're doing that, that's already in the box. There's another mechanism for token validation, which is called introspection, which basically means it's not a JSON Web Token, that the format is proprietary, so you contact the token service on a back channel, send that proprietary thing there, get the claims back in return. That's a standard protocol. That doesn't exist in ASPNET Core. I've written a handler for that, that you can get under this URL here, and you can plug that in and make that work as well. So that was a little gap, I think. Okay, so let's do this. Get rid of this, this guy. And this one, and go here. So what we have here basically is an application which, let's go to startup. Is an application, that uses OpenBody Connect for authentication, and it uses cookies for session management, and there's also an API that I want to call. So let's run this first to see how that works. So you see basically the from a programming model point of view, here's a controller. On that controller, oh yeah, I should mention that. We have a global authorization policy set up here which requires authenticated users. So whenever I click something which is protected, yeah, the handler will kick in and will send me to my authentication system. So let's do that. Click on the secure link. Okay, and now I'm sent to some external system that is using OpenBody Connect. I log in, doing some consent here, and I'm coming back, and remember that the callback implementation is done in the handler as well. This produces a claims principal for me, sets the cookie, and now I have the identity of the user available in my application. Remember that I mentioned that there are 2 parts to it. One is the claims, and one is the metadata of the authenticated user, so to speak. So the upper part are the claims, and you see that stuff coming from the token service. Yeah, my subject ID, my name, and my family name, and my email address, and these things. And when we look at the properties here, that is the metadata I mentioned earlier. And here you can see that Microsoft internally is using that to do some bookkeeping on the session. And as you can see, they don't care too much about cookie sizes, yeah, because that cookie is pretty big now. But there are ways to optimize that. But you see, basically, they have a couple of things in there, like, for example, the tokens, right? I mean, the result of that authentication process were tokens. These are the artifacts. Yeah, we have an identity token for the session management. We have an access token for the API access, and we have refresh token, so we can keep this token alive, in the background. And by default, as you can see, they're just storing all of that in the session. So the typical idea is now, when you want to call an API, for example, yeah, all you need to do is, where's my home controller? Yeah, you reach into the session. They have an extension method for that on the HTTP context. They just say, give me the token, okay? And then they, wherever you store that, that's abstract to you. You get back an access token for the current user, and then you can use that to call your API. Yeah? So that's one piece of the puzzle. We can see if this is actually working. Let's start the API as well. Yep. Oh, I want the browser. Okay, so that's working. So let's have a look at the API real quick. So here's the API, and you can see here we have this bearer token handler, which again points to the token issuer. It says, okay, my name is called API, so only let tokens in with an audience of API. And again, same idea. Token comes in, handler does the heavy lifting for you, turns it into a claims principal, and the claims principal is your user object, so to speak, in your controller. Okay? Okay, but there's more. So I mentioned here that here are your tokens, right? And one of the common problems with token-based systems is, well, they expire, right? So a token might have a lifetime of 1 hour or 1 minute, up to you really, yeah. But there will be probably situations where you want to use the token and it's expired. So you have to find a way how to refresh that token in the background and get a new one. And that's obviously a security mechanism because that gives us the ability to revoke the tokens, right? And there are many, many ways how to implement this background token management. One way, for example, which I like, is by using Microsoft's session management feature. Yeah? So let's see. That's the wrong one. Yeah, here. So basically, you can tap into the lifetime events, as I said, of the session management. And one of these events is called validate principal. And this is called every time the cookie comes in. So what I can do now is, for example, look at the tokens in the session, see if I have a refresh token, check the expiration of the current token, and if I reach a certain threshold, I will, under the covers, basically refresh the token and exchange the old access token with the new access token in the session, and your application code is completely unaware that this happened. It just says, give me a token, and someone else is working hard under the covers to keep this token fresh. Okay? The same thing we can do at sign out time here. Yeah, so when the user is signing out, the session gets destroyed. It would be good security hygiene to revoke that token, right? You don't need it anymore, so make sure it's invalid, and that's what this piece of code here is doing. You know? So if all of that is working, and I talked long enough, my token is expired. Okay? So the access token here is expired, so when I refresh the page, what we should see is that the access token changes. Also, the expires add should go into the future. So let's try that. Oh, that was a bad demo. And I can still call my API, okay? So that still works. I can guarantee you that it worked because my token only lasted for 60 seconds. So I think I talked more than 60 seconds, yeah. But yeah, isn't there a better way to show that to you? Maybe just refresh the browser. Nope. Okay, anyways, you have to believe me, I guess. Okay, so that is the whole summary of the authentication thing, yeah? Handlers, the authentication service, session management, external authentication, API access. That's the whole package, yeah? Shut that down. So, next topic, authorization. So now you know who the user is. Now you want to find out what is this guy allowed to do, yeah? It turns out it was really easy for Microsoft to innovate in this area because they had nothing before. So everything is better. So I've been giving feedback for a long, long time to the ASP.NET team that their authorization story is really bad, and I have seen so many homegrown implementations of all the things. And it kind of helped that a good friend of mine joined the ASP.NET team recently, well, not recently, a couple of years ago, as the security PM. So finally, somebody was listening to me. Yeah? So a couple of observations. Yeah, the way many people did authorization is using the authorize attribute, right? And that led to really bad code maintainability, having all of these attributes sprinkled, authorization logic and business logic in the same place. Because it was so limited, people wrote their own authorization attributes. And guess what? You have to know the magic keystrokes to make this work, yeah? Because you have to know do I call the base class first or do I call it afterwards? And it turns out in code reviews, even internally at Microsoft, many teams have implemented the authorization attribute in the wrong way, and they produced security problems. Yeah? So one of the goals was, well, a couple of goals here. First goal is separate the authorization logic from the business logic. Don't allow custom authorized attributes anymore. And my favorite one is make it testable. Right? I want to write some tests to verify that my authorization rules actually work, okay? Which is a good thing. It's a huge topic, okay? And if you want to learn more about that, go to this website here. That's the guy, Barry Dorrance from Microsoft. He is the owner of that system. He wrote a little workshop thing that you can follow along. It's pretty good. There are logically two things here. One is called policy-based authorization, and one is called resource-based authorization. They are slightly different ways to look into things. Let's have a look at policies first. So the idea with policies is that you're defining a so-called authorization policy, and that is really a list of so-called requirements. So, you know, to manage a customer, you need to be authenticated, you need to be in the sales department, and you need to have a status of senior. Okay, that's the policy. And then you can still use the authorized attribute if you want to, but then you just pass in the name of the policy, and that will, every time somebody calls that method, the policy will get executed, okay? So two things here. First of all, separation of concerns. If you have to change the policy, you don't have to change your controllers, they just get that. I think that's it. That's my, oh yeah, and you separate these things from each other, okay? The next thing, which I actually even prefer, is you can also programmatically talk to the authorization system without having to use the authorize attribute, right? So there's an I-authorization service in the DI container. You can get a hold of that. You call authorize async on it. You pass in the claims principle you want to run the authorization rules against, which is actually a pretty powerful feature. It can be your current user, but it can be also a different user in the system that you want to authorize against, yeah? Think of admin portals and other things, yeah? And then you pass in the name of the policy, and you get back basically a true or false. And this is also the key to testability. You can now write tests that create claims principles of certain shapes, yeah, like different types of users you have in the system. You run it through the policy, and you make sure it's returning the expected results. And if someone, you know, six months down the line changes your code, he will get immediate feedback if he broke any of the policies, for example, yeah, which I think is really, really important. What else do we have? Oh yeah. One issue I have here is, which is more like a perception issue, this kind of gives you the impression to use this authorization system, you need to have claims for everything, right? A claim for this, and a claim for that, and a claim for, you know, everything. It's very tempting to do that, right? Because you have this shiny new hammer, and everything becomes a nail suddenly. But you should, you know, claims describe the identity of the user, not what he's allowed to do. Identity should be the input to the authorization system, yeah, and the output should be the authorization decision. Yeah? So most documentation you see give you the impression that's how it works, and then people start modeling everything as a claim, which I think isn't a good fit. Yeah? So it turns out you can write your own requirements. Okay? So this one is a chop requirement. Yeah? So maybe imagine you have a controller that should only be available to managers. Okay? Pretty boring example, but you know, that's how it is. And basically what you can do is you can write your own handler in the system that gets called at runtime. They pass you in the details of the requirement, and then you can do whatever you want, whatever logic you want to run to determine if this user is allowed or not. And you see this I-organization service I have here in the constructor. Since these things live in the DI container, you can have arbitrary other dependencies from the DI container to abstract your data access, right? And that, again, helps with testability. Yeah? So you can have an you know, like a mock organization service, and the real one goes to your database or to your APIs or whatever. So that's quite cool. The The second one is called resource-based authorization. And the idea is, like the policies only look at who is the user, right? Whereas the resource-based authorization adds one more dimension to it, basically, which says, and what is he trying to manipulate in the system, okay? So imagine you're writing some sort of customer management thing, so you have customers and contracts and orders, for example, yeah? So you would abstract away all of your objects into so-called authorization handlers, one for customers, one for orders, and one for contracts, I guess. And then, you could encapsulate that in your in these handlers. When you then call them, the handler gets to see the actual instance of the resource the user is trying to manipulate, and then, you can do authorization rules based on that. And then you could call it something like this, right? You update a document, you call authorize async, you pass in the user, you pass in the document he's trying to update, in this case, right? And then, maybe the rule is you can only update documents that you've written in the first place, right? And that's something you can now encapsulate in that system. So again, a pretty big improvement, and maybe saves you from writing your own, custom system. Okay, I think I have a demo for that as well. Yeah, so that's, you see here, I'm having a couple of authorization rules here. One is basically saying, yeah, something that only salespeople can do, apparently, yeah. Something that only sales senior people can do, and something only the dev interns are allowed to do, yeah. And you see here is also an example of a, required job level. It must be a CXO type of person to actually, be allowed to do this, yeah. And then you can go to your controllers or to your code, rather. Where am I? Oh, yeah. And annotate your actions with these things. Obviously, you wouldn't use strings here, but constants and so on. Here's an example how to do it imperatively as opposed to declaratively. Yeah, so when I run that, I have a couple of different users. I think Alice is a salesperson. Okay? Yes, she is. Sales. Yeah. So if Alice tries to do something that only salespeople can do, that's allowed. If she tries to do something that only sales senior people can do, that should work as well. Yep. But if she tries to do the dev interns thing, like play the Xbox or something, then it's access denied. Okay. So yeah, that's just a quick glimpse into that. Obviously, there is much more to learn about these things, but it's meant to be an overview. The next thing you should be aware of if you're designing a system with ASP.NET is called ASP.NET Identity. It's Microsoft's user management library. And it has been around for many years, and the first couple of versions were not that great, to be honest. Yeah, we gave a lot of feedback, and it took a long time. But with the latest version, or the latest two versions, I think, it's pretty solid, it's pretty good, and it saves you a ton of work. If you have to build an account management system, like with names and passwords, imagine all the complexity here. Creating the user, creating the passwords, saving them, storing them securely, resetting passwords, changing passwords, email confirmation, multi-factor authentication, all the things you have to do, it's all in there. And it's been reviewed by security people, and it follows best practices and so on. So if you have the luxury of building your own user database, right, most people I know already have one, okay? So, but if you have to, well, luxury is maybe the wrong word then, but if you really have to, I would totally recommend using this library. Yeah. I even have customers that slowly migrate, like on the login page, user comes in, he logs in, they first check the old database. If the user exists, they migrate him over to the new database using this, just to get the benefits of all the extra things, like, as I said, changing passwords, resetting passwords, all the ceremony around that, sending emails with tokens, clicking a link, coming back, it's a lot of work, okay? So, the last missing piece, so to speak, is, so Microsoft has this ASP.NET Core. That's great. Yeah, they have an identity management library. That's great too. The only thing they were missing is basically now, is there, can we now participate in token-based authentication in the sense of issuing tokens so that we can secure APIs? And that was always missing, or they had a couple of attempts to do that, but they finally came to their senses and talked to the right people, I guess. So that's the only new thing I can really show you, because it's the only new thing right now, is starting with .NET Core or ASP.NET Core 3.0 Preview 3. Whenever you are doing API authentication, like in the API template or in the SPA template, whatever, they now incorporate IdentityServer, the thing I'm working on, in the templates. So, and the idea was, you could do that since forever, but the idea is now that this makes it easier for you to get started, because there is a certain amount of configuration you have to do in IdentityServer, and that these are just keystrokes, right? But you need to know why you're doing it. Yeah? And the idea of Microsoft is, you know what, while I'm talking, I should load this. The idea is that basically you get a file new project experience. It has an API in it, it has a SPA in it, it has IdentityServer in it. The SPA is set up to do OpenBody Connect and OAuth to get a token and to use this token to access your APIs. And you're automatically following the best practices thing. You don't come up with your own security infrastructure. You don't try to abuse cookies for things that they are not meant to. And then you can grow from there. Yeah? Obviously, a single project containing everything is not really realistic. But if you just want to get started, that's good. And then you can start separating the things, separate the API from the UI, and and so on. So you wouldn't believe how long it took Microsoft to finally accept the fact that maybe an open source solution is the better one than building it themselves. Yeah? And we had many, many discussions with them. And one of the main things is Microsoft wants to have it in zero config. Okay, so basically no one needs to understand what they're actually doing, just press F5. So let's have a look at that. So that's the new Angular template in, That's the new Angular template. So they will have a couple of templates. They're using that. The first one is the Angular one and the React one. I'm pretty sure there will be a Blazor one at some point, and the Web API ones as well. So you can see here basically what they're doing is they're just bringing the pieces together, really. So here is where they add their default UI for registering users, for logging in, for logging out, all these things, right? And basically now they are marrying this together with IdentityServer, and here's the magic extension method that Microsoft wrote, which is the zero config one. Okay, so under the covers they're wiring up all the things now, the keys, the clients, the resources, and everything. Okay, so let's run it. It's actually amazing how much work is needed to run an Angular application these days. Look at that, compiling stuff. It's also amazing, when you create this template and you run it for the very first time, it does an npm restore, so it has 60,000 files. Yeah, it's complete madness, yeah. Anyways, so, I'm logged in. Okay. So you see, basically, you get this basic template here. When you click register, it just goes to a register page. I guess that's not exciting. When you click login, they do a couple of clever things here. So basically, they also took our JavaScript client library and wrapped that up as an Angular component and as a React component. So when you press login, what they first try to do is open a pop-up. Yeah, and the idea is, if you get away with a pop-up, then you don't have to reload all of your state in your SPA when you come back from the authentication server, which is often a point of criticism, right? That you have to go to another site and come back, and depending on how complex your state is, you need to store it somewhere, and it takes a long time, and so on. So they first try to do a pop-up. If the pop-up is not allowed, maybe on a mobile device or maybe because of a pop-up blocker, then they do the front channel redirect to the server and come back to you. Which, I think you can configure it, but I think that made sense to me. I mean, I don't know anything about front-end development, but it sounded reasonable. Okay, so I can log in. Now, IdentityServer under the covers is doing all its magic. It's validating the request and the user and creating tokens and so on. So now, basically, all we need to do now is write APIs, right? Here's a controller. Now, hold on, where is my... Oh yeah, sample data controller, sorry, here it is. Okay, so all you have to do basically is just put the authorize attribute there, and the client side will now send the access token. And yeah, and we get, finally, that the values controller is gone, we now get metadata. Exciting, huh? Okay, so that's a quick preview. I mean, you can play around with these things today. You have to install ASP.NET Core Preview free for that, 3.0 Preview free with Visual Studio 2019, which I think will next week go RTM. So it's pretty, it's happening soon. Okay. There are more plans around this feature area than just doing the SPA template. Think of microservice architectures where you have many APIs talking to other APIs. So we will work on things like separating the APIs from the IdentityServer, deploying them in different ways. But also a really interesting thing where we will do is, imagine you bring up a new API, and normally you would now need to go to IdentityServer, register the API, configure to which resources the API has access to, and all these things. So there's a protocol called Dynamic Client Registration, which we never implemented, but now is the time, I guess. So that basically you can have an architecture where you bring up the API goes to IdentityServer, registers itself, okay, so no configuration required at the token service for the new API, and immediately is able to get tokens from the token server and can talk to APIs. Okay? So that's pretty much it. What time do we have? Any questions? We have 8 minutes left. Do you have any questions? No? I have stickers. Not many, to be honest. Yeah. Normally, I always forget to bring them up. This time, I even forgot to bring them here. So, but I have a couple. Okay, so if you want them. Otherwise, thanks for your time, and have a nice day.